Okay, good afternoon. On my behalf, next 15 minutes, it will be discussion about modernizations and upgrades with a more recovery. And this will be a topic around the automation, how automation can contribute in this area. My name is Ari Rantala. I'm managing our advanced process control and automation solutions in Outotec. This is showing a typical first lifetime and life cycle phases of a concentrated plant. There are familiar phases for the ramp-up and stabilized phase of the plant, where you are reaching the nominal capacities or the target capacities, and then optimizing phase of the plant, meaning different things, optimizing the existing operation or making expansions or renewing equipment. So what is important in different levels? First, in the ramp-up phase, it's important to get the basic things right. Formulate safety procedures, be sure that everything is safe on the automation side, interlockings are working. Make sure that the instruments and analyzers are adequate. It's a good level of instrumentation and information from the process in order to make a really good automation level at the plant when it's running on the later stages. Training is a key thing for a new plant when there are typically new operators, maybe not familiar with operating the minerals processing plants at all. And it's very important to nowadays formulate good data collection environment, just to start collect every data that is available at the plant when it starts up. It will be really useful at the later stages. Next, in the stabilizing phase, it's important to assess the automation level, the controls, what have been implemented, are they tuned? Typically, they require some fine-tuning. Typically, advanced instruments like front cameras or level instruments are applied in this stage. The main thing is to provide stable operation for the operators after the successful ramp-ups. Now, the data that has been collected and is collected can be used for the analysis, to start learning from the process. How is our process operating? What are the characteristics of the process? Also, reporting, systematic reporting and KPIs are important to be implemented latest this stage in the plant. When we are starting to optimize after the plant is stable, it's important to start working on the performance assessment, work further on the loop tuning, do it regularly, because that is affecting to the plant performance a lot. Understanding the process more deeply, the ore, how it is going to change in the future. And in this stage, it's reasonable to start working on the optimizing. Quite often, optimizing is here already. There are some work done for optimizing, but it's really difficult because we are so early phases at the plant when it's ramping up. Optimizing requires a lot of information about the process and its characteristics. Also in this phase, upgrades of the existing equipment and applying new equipment is really beneficial. And having good service contracts, good service support, and good maintenance procedures for all the equipment installed, it's a key thing to success. The same approach can be used for brownfield operation with variable level of automation at the plant. There might be really old plants running well, but there might be a need to improve the automation level of the existing operations. There, it's very important to remember also the same approach here, that work on the base level first, that you have adequate instrumentation, analyzers, process control that is tuned before going further for front cameras or advanced instrumentation or stabilizing controls. And after that, apply the optimization, which is quite often it's a quite long and actually continuous process at the plant. Our grinding control, traditional grinding control solution is shown in this slide. It starts from the instrumentation, typical instrumentation level that should be available at the grinding circuit if stabilizing or advanced process controls are reasonable to be added to the plant. There are special instruments for particle size called PSI 300 and PSI 500 from Outotec that are measuring actually the final product of the grinding circuit. So very important measurement to really optimize and work on the capacity and the quality of the grinding circuit. PSI 500 is based on the laser diffraction method, and this PSI 300 is based on the mechanical moving head principle. Actually, it's an upgrade product for the PSI 200 earlier model that those are still, hundreds of those are still running at the existing concentrator plants. Then process control system is controlling the circuit, and there is an ACT advanced control package from Outotec that is used to apply advanced control strategies to the grinding circuit. It is connecting to the existing control systems at the plant well. Then integrity system is collecting all the process information in the central database, allowing reporting and data analysis to be performed at the plant and to optimize it. Here are our standard grinding optimizing modules for the grinding, again separated on the stabilizing objectives that should be implemented first in order to really stabilize the plant and increase its controllability. It's for the mill feed and power control, circulation load control, particle size control, cyclone battery control, and ball addition to mill if there is equipment available for that. Then optimizing objectives are working on top of these modules. Typically we are speaking about throughput optimization in the grinding circuit. So try to maximize the throughput and also energy consumption. Flotation control, a little bit more instrumentation and analyzers there. Samplers are very important around this process for process control, to take the samples around the full mass balance area or sub-mass balance areas in order to determine the grades and recoveries online. Courier, well-known elemental analyzers are measuring the elemental contents of the slurries, providing very important information for the process control. We have a new analyzer called Jena for measuring the electrochemical potential of the slurry. It can be used to optimize the reagents and also selectivity of the flotation in certain flotation applications. Our samplers, there's a good set of samplers available for process control and also for metallurgical sampling called MSA. Then a newer product for slurry level measurement called Level Zones that improves the slurry level measurement and also allows some advanced options for froth characteristics estimation. FrothSense froth imagers to measure the froth speed, bubble size, color on top of the flotation cell, and cell station is a unit controller for the level and air in the flotation. Okay. Java update. All right. Then our grade recovery optimization on the flotation side, a little bit similar principle than on the grinding, is based on the standard modules implemented in our ACT expert control software. There are stabilizing components for the froth velocity control using froth cameras, FrothSense system there, and optimization utilizes the elemental assays of the Courier analyzer, and when optimization is applied, the set points are applied to the froth velocity set points and also the reagent addition. This is very typical way to structure optimizing of the flotation circuits. New analyzers I have already introduced shortly. So level sense slurry level measurement for measuring the slurry level in the tank cells or flotation cells based on electrical impedance tomography. There is a small demo unit available at our booth if you would like to know more about that. Then we have introduced this year new online light element analyzer called Courier 8 that allows measurement basically the full table of elements, and the applications are of course very interesting for the aluminum, silica, magnesium for the light elements where we cannot apply the X-ray analysis methods. Then Jena analyzer is useful for some flotation applications like molybdenum flotation, where you can find a suitable flotation area environment where the selectivity is good between the EH and pH. Here is an example from level sense, two level trends. This is showing the traditional ball float measurement from first quantum plant in Kansanshi in Zambia. This was what they used to control some of the flotation cells. And when the level sense was installed, actually it was discovered that the slurry level is in totally different position. And this has a dramatic effect on the flotation performance if you discover that. And here is the control signal showing the set point and the measurement. Now it has been in a control for 3 or 4 months. Very successful and happy customer there. Another example about the importance of the basic level controls is the level controls of the flotation cells. If you use individual level controllers in the control system, if you introduce the flow disturbance, you typically see that there's a disturbance on the level controllers as well that is typically gaining along the bank. And when you have an exact level controller from Outotec that provides the feed-forward compensation, you don't see this disturbance effect. This disturbance having an effect to the level anymore. So this has a dramatic effect on the level stabilization and level control performance. Another useful application for the stabilization of the flotation cells is the use of froth camera systems to stabilize the mass pool. Here's a happy operator looking at the camera here on top of the big flotation cell. And this provides online analysis of the bubble sizes, and the froth velocity. Here you can see that the operators actually don't have to work anymore on the individual airs and levels in order to control the flotation cells. Now they are providing the set points only for the froth speed, and the system is managing the control. Here is the grade recovery optimizing after you have applied these stabilizing controls. It's showing a real example from one copper nickel operation for the grade control, where the system is defining high and low limits for the grade, and the system is controlling with the reagent addition and also the froth velocity set points, always the grade and also recovery. Oops. It's very important to service the system all the time because there are always changes in the plant. So if you don't manage the service and maintenance of the system, they will eventually degrade at the plant. So this is very important aspects in order to maintain and benefit from these systems. The training for the operators is very important, and we have a virtual process training for the operators available, running our HSC process simulation, dynamic simulation on the background. Has been implemented successfully to some sites. And recent success stories for flotation optimization in a copper nickel mine, increase of recovery by 1.3%, about 200 tons of more copper each year. Courier 6 analyzer increase in 0.5% increase in copper recovery and reduction of the laboratory and reagent costs, and level system used successfully in automatic level control in Kansanshi, Zambia. We have a very extensive set of references. We are market leaders in many of our analyzers and control applications around the world. And that's my time, I guess. Thank you for your attention, and please come and visit our booth. 160, I guess, is the number, and we are happy to discuss more about these applications. Thank you.